Ever wondered about the age of the universe and its earliest beginnings? Let's dive into some facts. Picture this: the universe we're part of, this vast expanse of everything we know and beyond, is approximately 13.8 billion years old. Quite the senior citizen, wouldn't you say? But how did it all start? Enter the Big Bang, the universe's fiery debut. This wasn't an explosion in space, as the name might suggest, but an explosion of space. The universe began as a singularity, an infinitely small, hot, and dense point. From this singularity, the universe started expanding, growing larger and cooler. In the early moments after the Big Bang, the universe was a hot, dense soup of particles. It was so hot and dense that atoms couldn't form yet. It took around 380,000 years for the universe to cool down enough for the first atoms to appear. And what were these atoms, you ask? Mostly hydrogen and helium, the simplest and lightest elements. Now, if we could time travel back to these early times, we wouldn't see much. The universe was filled with a dense, hot fog of particles and radiation. But as the universe expanded and cooled, this fog cleared. The radiation left over from these early times can still be detected today. We call it the cosmic microwave background radiation, a faint glow that permeates the universe. One intriguing idea is that the concept of time as we understand it may have originated with the Big Bang. Before the Big Bang, there was no universe, and thus, no time. With the birth of the universe, time began ticking, marking the cosmic history that led us to the present day. So our universe started as an incredibly hot and dense point, expanding over billions of years into what we observe today. It's a story of unimaginable scales and times, of heat and particles, of expansion and cooling. And we're just getting started with our cosmic journey. What fills up this vast universe? You might be surprised by the abundance of certain elements and the scarcity of others. The universe as we know it is a colossal, ever-expanding space teeming with a multitude of galaxies and stars. It's estimated that the observable universe alone is home to at least 2 trillion galaxies. Each of these galaxies contains billions of stars, a figure so large that it dwarfs the number of grains of sand on all the beaches on Earth. It's a mind-boggling reality that underscores the universe's sheer enormity and diversity. But what are these galaxies and stars made of? The most common elements in the universe are hydrogen and helium. These lightweight elements form the building blocks for stars, galaxies, and by extension, the universe. They're so abundant that they make up nearly all the ordinary matter we can observe. Yet, there's more to the universe than meets the eye. Dark matter, an elusive substance, makes up about 27% of the universe's mass energy content. Despite its abundance, we've yet to directly observe dark matter. It doesn't emit light or interact with electromagnetic forces, making it incredibly difficult to detect. We only know of its existence because of the gravitational effects it has on galaxies and large-scale structures in the universe. And then there's dark energy, another mysterious component of the universe. Although we can't observe it directly, scientists believe dark energy is responsible for the accelerating expansion of the universe. It's thought to make up a staggering 70% of the universe's total energy content. From countless galaxies to elusive dark matter and energy, the universe is an intriguing mix of the known and the unknown. It's a place where the most abundant elements are the simplest, and where the most influential forces remain unseen. But with every new discovery, we inch closer to understanding the complexities of this vast cosmos we call home. Now hold on to your seats as we explore the dynamic nature of our universe. We've all heard the phrase, space is big, but it's not just big, it's also constantly growing. Yes, you heard that right. Our universe is expanding. This mind-boggling phenomenon implies that galaxies are consistently moving further away from each other. And this isn't just a leisurely stroll. The universe is expanding at an accelerating rate. The discovery of this acceleration came from observations of distant supernova, those explosive ends of a star's life, illuminating the universe's secrets for us. But what's the force behind this rapid expansion? Enter dark energy, a mysterious form of energy believed to be the driving force of this acceleration. Dark energy is like the invisible puppet master, pulling the strings of the universe, making galaxies dance farther apart. However, dark energy remains one of the most elusive entities in cosmology. defying our conventional understanding of physics. And as if an expanding universe isn't mind-boggling enough, brace yourself for the inflation theory. This theory proposes that the universe underwent a rapid expansion in the first few moments after the Big Bang. Imagine a tiny seed, smaller than an atom, suddenly blooming into a universe-sized entity in a fraction of a second. That's the inflation theory for you. The evidence of this expansion is also visible in the phenomenon known as redshift. As light from distant objects travels through the expanding universe, it's stretched to longer, redder wavelengths. This redshift is a cosmic clue, a telltale sign of our universe's dynamic and ever-changing nature. And here's the kicker. The universe isn't expanding into anything. It's not like blowing up a balloon in a room. Instead, space itself is expanding. The fabric of the cosmos is stretching, creating more room for galaxies to drift apart. Intriguingly, our universe isn't just sitting still. It's constantly expanding and at an accelerating rate. Just imagine, even as we speak, the universe is getting a little bit bigger, a little bit more mysterious, and a whole lot more fascinating. Ever heard of black holes, neutron stars, and quasars? Let's delve into these exotic phenomena. Imagine a region of space-time where gravity is so strong that nothing, not even light, can escape. These are black holes, the universe's most mysterious objects. The largest known black hole, Ton 618, possesses a mass over 66 billion times that of our Sun. And yet, at the opposite end of the scale, we have the smallest known black holes. These are microscopic entities known as primordial black holes, an intriguing contrast to their gargantuan counterparts. But the universe's exotic nature doesn't stop at black holes. Meet neutron stars, the incredibly dense remnants of supernova explosions. These stars are so dense that a teaspoonful of neutron star material would weigh about 1 billion tons on Earth. That's roughly the weight of Mount Everest, all condensed into one tiny spoon. Then we have pulsars, a type of neutron star. These celestial bodies are fascinating because they rotate rapidly, emitting beams of electromagnetic radiation. These beams are so precise that we can use them to keep track of time, much like the universe's own cosmic lighthouses. And finally, let's talk about quasars. They are incredibly luminous and energetic regions surrounding supermassive black holes. In fact, they are among the most powerful and brightest objects in the universe, outshining entire galaxies. Quasars are so distant that the light we see from them started its journey when the universe was just a fraction of its current age. Our universe is a cosmic stage where these dramatic phenomena play out. From the inescapable gravitational pull of black holes to the blinding light of quasars, these exotic elements of the universe push the boundaries of our understanding. They invite us to ask questions, to explore, and to marvel at the grandeur and mystery of the cosmos. From black holes to quasars, the universe is teeming with exotic and extreme phenomena that continue to baffle and fascinate us. What does the future hold for our universe? And could there be other universes out there? As we gaze into the cosmos, we see the dance of galaxies, each with its unique rhythm. Among these cosmic ballets, one event stands out: the inevitable collision of our Milky Way with the Andromeda Galaxy. But don't pack your bags just yet. This celestial event is about 4 billion years away. When it happens, it won't be a collision in the usual sense. Instead, the galaxies will pass through each other, their stars so far apart that they won't collide. Eventually, after a cosmic tango lasting billions of years, they will merge into a single, larger galaxy. And what of the shape of our universe? Based on measurements of the cosmic microwave background, scientists believe our universe is flat. Think of it as an infinite sheet stretching out in all directions. In this flat universe, lines that start out parallel stay parallel, and the angles in a triangle always add up to 180 degrees. It's a simple, elegant geometry that seems to be the backdrop for all the cosmic structures we see. But is our universe the only one? Enter the multiverse hypothesis. This idea posits that our universe might be just one among potentially infinite universes. Each of these universes could have different laws of physics, different types of particles, and entirely different histories. It's a mind-boggling concept, and while it's still in the realm of theoretical physics, it's a tantalizing idea that could redefine our understanding of existence. Finally, how old is our universe? By studying the oldest stars and the cosmic microwave background radiation, scientists estimate it to be around 13.8 billion years old. It's a testament to the power of science that we can make such a precise estimate about something so vast and ancient. From potential cosmic collisions to the exciting possibility of multiple universes, the future of our universe is as intriguing as its past.